So in this video, I'm going to talk about Archimedes' principle and Pascal's principle, and this is from chapter 15.4 and 15.5 in the textbook. Okay, so first off, Archimedes' principle. So Archimedes' principle tells you about buoyant forces. So if you immerse an object in a fluid, and again, if you've ever been swimming, you've probably noticed this before, the fluid actually exerts a force upward, so that's called the buoyant force. Now the magnet, and it's actually kind of easy to see where this comes from. So in the last video, remember we talked about how pressure increases with depth in a fluid, in a static fluid. So now imagine if you have an object that's immersed in your fluid. So actually the pressure, since the pressure increases with depth, the pressure pushing up on the bottom is going to actually be larger than the pressure pushing down on the top, and that's where the buoyant force comes from. And if you do a little math, you can figure out that the magnitude of this buoyant force on an object immersed in the fluid has to equal the weight of the fluid displaced. So the buoyant force, F sub b, the magnitude of the buoyant force, I should say, is going to be equal to the density of the fluid, rho sub f, the volume of the fluid displaced, and so that'll actually give you the mass of the fluid displaced, multiplied by acceleration due to gravity, and that'll give you the weight. So the other important principle is Pascal's principle, and Pascal's principle says that if you have a pressure change in a fluid, the pressure change is transmitted undiminished throughout a confined fluid. So, and this is exactly how things like hydraulics and pneumatics and even a tube of toothpaste works. So if you have some combined fluid, so imagine you have a tube and the little pinkish orangish stuff here is your fluid. If you exert a pressure on one side, so that pressure is transmitted undiminished throughout the enclosed fluid, so if you have, say, an input piston, you exert a pressure on the input piston, the same pressure gets exerted on the output piston. But remember, it's actually the pressure that's the same from one side to the other. So, and pressure is force over area. So if you have a small area over here on the input side, so a small force over a small area is your input pressure. The pressure on the output side is the same. So if you have a larger area, you'll get out a larger force. And that's exactly how hydraulics and pneumatics work.